a lot of mixed pixels as well. So then you need to make it a more clear and more filtered image. See, there are a lot of mixed pixels in between, which is practically doesn't look so good, isn't it? Therefore, you like to filter them out. So here you can design what kind of filter you want to use. So that, let's say, you do not want to have 2 or 3 types of classes in one big polygon maybe. Okay, let's say forest. In the forest, if you use this particular type of algorithm, inside the forest also maybe there are some roads. Inside the forest also there may be some other types of vegetations, but I don't want. I don't want the small patches in between there, looks like clutter kind of thing. Yeah, I want the whole thing as a forest. Okay, so therefore you can use actually the filtering to smooth out. Okay, so you can see that you can, after filtering here in this case I use a little bit bigger filter 5x5, because you are smoothing the image. Then once you do that, then you can classify them. So in this classification we got 4 types of forest: hill forest, lowland forest, some developed areas, okay, that is forget about it, and another one is the urban tree. Urban tree means like the Japanese trees you all are planting. That's not a wild forest, isn't it? Correct. That's an urban tree. Yes? So that's how you can see it, very simple. But I explain how step by step you can be able to achieve that. Then you need to go and do the validation. So you see, for different types of forest, then you have to go and collect and see, and you have to do a proper validation. Okay? This is urban here. Correct? Developed area. This is hilly forest. This one is lowland forest. Those who are from forestry background, they will have to give more information than us. Okay? So at least something for forestry guys. Now let's move into geological interpretation. Okay? Geological interpretation is basically we are talking about the structural features like linear features, the lineaments and faults. Let's say my study area is Salam. Okay? I want to map all the faults and the lineaments in Salam. Okay? Possible. Correct? Then you can ask why I need to do that. I can go and buy actually the geological map from JNT, the alternative conditions. So how they did also? They also enhanced their map based on this technique. Because the British people have done the map 1800 something. Okay? So these are the techniques that you can use. See here, first thing, what are the process? I want you to think. Get the image. Geocode it. Then enhance it. For 3 image processing steps. Correct? Then you want to do some enhancement like contrast stretching, band ratioing, or maybe you want to do some thresholding and so on. Yeah? So this is the raw image, you can see that. Once you do the geocoded and everything, it's a bit enhanced here. And these are all clouds here. Not snow, huh? We'll be happy though. Okay, then to extract the linear features, you have to apply some filtering. Basically the edge, correct? Directional filter. Yeah. So you have different types of directional filters depending on it's west or south or north, west, southeast, and so on. You can straight away apply, and it can delineate actually the different types of. Also, there are more sophisticated filtering techniques are available, like Laplace filtering and so on. So all this basically you need to do. If this is your topic that you're interested, you need to do a bit of literature. Definitely. All the topics that I'm mentioning, applications I'm mentioning, the great volume of work that you can find through your literature review. Literature review is a must because that is the backbone of your research. Defining the problem statement, coming up with your research gap, everything comes from the literature. A thorough, strong literature review is extremely important. So this is whatsoever you do. Research means research, literature. So let's go back to the literature. Okay, if you come up with some findings which not necessarily agree with majority of the literature, but still you can argue with somebody else is also supporting your idea. Right? So always the supporting thing has to be there. The citations, the referencing, supporting or corroborating on your work. Okay? So that's very important because all the reviewers, they are the examiners also, they will be always looking at these aspects. Okay, so once you apply these filters, we extracted, these are the linear features from the image. Yeah? So 3 sets of linear features that we extracted. So we found northeast, southwest, and then northwest, southeast, and east west. East west is this, right? These are the east west. Then we have northeast, this is northwest, southeast, right? This one. Then this one is northeast, southwest. Correct? So this is complementing to what actually probably a geology map will have. The geology map will have basically 2 important information. One is the lithological information and plus the structural component, the folds and the lineaments and the forms. Right? So this can, and then in addition to this, the radar also plays a very, very important crucial role in terms of identifying the features. So by this image, we did this much, right? But if you use radar, probably you can find hundreds of lineaments, much more than that. Small linear features also you can be able to identify. But then again, you also need to check with the structural geologists, you know, to qualify a linear features to be called as a fault. Lineaments can be anything, but to be called a lineament as a fault, it has to be a fault. Right? So a structural geologist who has good amount of knowledge in photo interpretation, image photo interpretation, would be a qualified person to validate that. Okay, so then you need to do also ground routing, so which we did. For example, here you see that hot springs. Then the river is flowing and suddenly it follows a straight line. That is a fault, major fault. Okay, so these are actually the indicator of the fault lines. So then you can see also along the fault lines, you see actually quartz veins, because these are the weak zones on the Earth's surface or the cross, whereby actually the mantle has pushed in later part and finally crystallized through quartz veins. Okay, silica veins. So these are the places actually where even the gold hunters also they look for gold veins, quartz veins. Okay, now, and they see, I put some clues here, Thread River, quartz vein, hot spring. These are actually the indicator for a structural geologist to look at actually the fault. Alright. Then, see here, this is what actually we extracted separately from the image. Then you have the rivers, of course, and then this one is extracted from the remote sensing image. And this one is already given by the available published JMG. Okay, so basically you are complementing the information that is in there. So basically you are using the remote sensing as a tool, source of information to enhance your data. Okay, so that is what we call SIM, satellite image maps. Okay, here. Then you put it on your lithological map, and it's fantastic. Right? You see now I put it on the lithological map, you can see that all the linear features that is there. Are you all understanding or not? Okay, this I can see. This is radar. Mostly it's the DM splicing. It's okay, I can see this. This also I have already shown you. It's a simple change detection in the disaster applications. I have shown you the Kelantan. This is the river Kelantan, and these are actually from different flooding time. This is back in 1998, but different time. This is on 22nd of December, this is 29th of December, and this is 8th of January 1999. So this is dedicated to one flood, right? But how the flood has evolved, you can see that. When I will give a full lecture on flooding, flood, there you will see a lot of digital information, so to speak. Okay? But this is the radar image. This is the radar image. You can see here. Well, as you know, that radar is very sensitive to water. Correct? So you see that clearly. This is the peak of the flood. Okay, this is the peak of the flood, and then you see the. Then you can be able to map them as well. See here. These are the areas which is the normal water bodies. And the green areas actually is the waters that has been injected. Agreed? Understood? Good. Any questions that you have? I still have time. Yeah? If you have questions, please ask. Time is running away. This is 4th week or 5th week? 5th week, huh? So, if there is none, sure none, no question now. Basically, what is on in this first class? Summarize. Please summarize. What have we done? I mentioned basically is the feature extraction, the ways to extract the features, the general steps actually to follow, classification skills that you get. See, I know. Then also we discuss about the edge detection. Yeah, the Sobel, the gradient filter, and then also we discuss about different types of forests and how we can classify them, and then also yeah, so basically it's all about features, right? So now this is also very good case study. Yeah, water quality monitoring using the motion. Of course, GIS is also important. So, water quality monitoring means physical senses basically monitoring the water quality. Water quality means whether it is full of pollution or sediments. Yes, that's right. So, whether full of pollution or sediments. Yeah? How can we engage remote sensing to do this job? Is it possible? Possible. No, simple question we must ask ourselves. Possible or not? Possible. I have a class here. No, we have, when we say the possibility, we have to look at actually basically the satellite and the band select. Right? So, what? Which? Radar is good actually to identify the water bodies. But that's it, because you don't get anything from that. Because this comes as a dark. Right? So basically, if you want to analyze something inside that, so you have to go into basically the multispectral. Not in panchromatic, you have to do multispectral. So which band will be useful? Huh? Blue. Yes, fine. Blue.
200. This with related with chlorophyll. Chlorophyll. Chlorophyll go to green.
في الشارع خزي في الشارع.
What? Remote sensing of what? Remote sensing of ocean. See. What are the satellites? First class, huh? Remind back. See, always I would have given you the clue, I would have given you some information on this. First class, if you remember, I have clearly actually segregated the type of satellites into different applications. Right? I mentioned that low resolution satellite, moderate resolution satellite, high resolution satellite, and so on. Which satellite out of that was useful for water quality? Answer is good. Yes. Both.
سبوت 4
Both.
This is good. Yes. Why? Then you have to look at it. What are the senses they carry? That's it. Seaweeds. Seaweeds actually is a satellite specifically meant for ocean mapping,
Iberian.
chlorophyll mapping, or we call ocean color mapping. Ocean color is nothing but actually the chlorophyll content mapping. Okay? See, all the whole applications comes back to that basic question. You know, if you don't know the numbering system, how to do high level of calculus? If you don't know 2 plus 2 equals 4, how to do go into dx divided by dy equals to square root, blah blah blah. How to do it? Correct. So always go back to those. The first class, that's why I spent some time to go through which band I mentioned actually is good for what applications. Very, very important. Huh? Okay, so now let's look at how we can engage remote sensing for water quality management. Objectives: to develop methods to retrieve water quality parameters from satellite. Okay, clear? Clear objective, no confusion here. To generate water quality maps. Also another deliverable, straight away. So I want to find out actually a map showing the degree of pollution in the water. But in terms of what kind of pollution, there are different parameters that we use now. Correct? You have TDS. Correct? TDS is total dissolved solids. Then you have POB, COB, and so on. There are different parameters that have one. Okay. There are 2 study areas we took here. First is the Chini Lake, Tasi Chini. Okay, this is in Pahang. This is the biggest lake actually in Malaysia, landlocked lake in Malaysia. Huh? So, sorry, second largest lake in Malaysia. Then you can see here, most of the time you have actually, it's very difficult actually, some areas, it's very difficult to get actually a cloud-free image. One actually also, once we pass through Jalapa, what's the city? The one we have maximum number of rainfall?
Ipoh.
No.
Gothenburg.
After
Kuala
Jalapa,
Kangsar.
and also the resort that they have now recently actually
Kamera.
Camera, but after that the town. That's the max. In Peninsular Malaysia, that's the area actually you have quite a lot of rainfall there. Okay, so never mind. So you see that the area is quite big, huh? More than 12,000 acres. Second area, second study area, I think it was Langkawi. I think it was Langkawi. Okay, we'll see what it is. Okay, why this area? Before I can justify to get some money, why this area is important? It's very important. Anyway, it's very important. If you want to ask money to spend, you have to justify why it is important, socio-economically. That is your contribution, huh? So, well, this is a very beautiful scenic place and blah blah blah. But anyway, in terms of biodiversity, it is very important. Yeah. So, the second area is Langkawi. Okay. So Langkawi, how many of you have been there? Especially the very good. Pass. Yeah, it's a beautiful tourist place, isn't it? It's a beautiful tourist place. It is a combination of more than 100 islands. Okay, more than 100 islands, small islands. And also, this used to be, this together with Tioman, used to be one of the most cleanest. Used to be. Yeah? Used to be. So that is why it was a good time for us actually to ask some money to know what actually has happened. Yeah. So this is another study we took. Okay, you can see this is Penang. This is Langkawi. Okay, two studies. Well, beaches, then you have mangroves area, beautiful, and so on. Yeah, very nice. Software that we use was in week. So it depends. Just imagine maybe some of the tools are useful. I mean, more easy to implement some of the processing. SPSS depends. This is a mathematical software, isn't it? This is statistical software. You can use Mathematica as well if you want, or any statistical software. But I feel comfortable with SPSS, so SPSS. Then ArcGIS, at that time 9. Now you are in 4. Okay. Now, this is very important. In order for us to do water quality mapping, that means we are relying on a satellite image to extract some of the parameters from the image, right? But for that we need to do very extensive field survey. Correct?
Yes.
And you need to do your field survey at the time when the satellite is very fast. So it needs very careful planning. Let's say you have decided to use Landsat. Let's say the Landsat next pass. Then somebody is asking what is the path, the satellite they have a designated path to follow, which path, which row, and so on. So then we know that the next orbital pass of this particular satellite, maybe Landsat, will be maybe 10th of January. Say 10th of January. So you need to plan. During that time, you should be in the field when the image is captured. But this is a very expensive affair. Thinking that nothing goes wrong. But if it is a cloudy day, basically all your efforts, all the money that you have spent on your data collection is gone. Because you cannot do any calibration. And you need to do calibration. What you are measuring in the water, it has to be well calibrated to what you are capturing on the image. Right? So it needs a proper, careful planning. So what we decided was, for Tasicini, the first area, we use Spot 4. Okay? The acquisition time, you can see, this is very old, some time ago that we did the project. I did the project, so it was in 2004, 16th of October. Okay? This is the product level, spatial resolution is about 20 meters. Okay? The second image, the acquisition time is 9th of September. Okay? See here. For second study area, we use the Landsat because mostly ocean area. Yeah, so it is expensive also to use Spot 4, and you may not actually capture the whole area through one pass. That's one of the reason as well. Okay? So it was 17th of January 2002. So, 14 years ago, huh? That's it. That's it. Okay? And then also use for what is there. In this case, 2003, 10th of April. Okay? You need some ancillary data. You need the topography map, the digital one. You need some vector data as well for you actually to do a proper planning of your field, locations that you want to visit and so on. Also, a planning for your capturing the field, right? See, the first was 16th of October. So we plan actually to collect the 16th of October. That means a month, 2 months before, knowing the fact that the next pass will be on this day, also knowing the fact that this is the time, this is the time of the year where actually we may not have so much of cloud, because your clouds are finished. Correct? Then Langkawi we did in 17th of January 2002 and 10th of April 2003, referencing to these two days. Exactly. Okay? So, what we did, basically we did actually for whole Malaysia, but I am showing you for these two study areas. Okay? So you can see this is the locations, the field data locations. You can see this is how actually the distributed, well distributed over the lake. You can see or not? This is the shape of the lake, isn't it? Like an octopus. But then we have connected here. Okay? Yeah. Yeah, this is in the south. Also we did, you can see actually we have done a lot. But anyway, so I'm just trying to show. This is in Perak, Uni, and this is Serangan, Uni, and this is Walanga. Okay, see these are the locations. 2, 3, 4, 5, 6, da. Most things are good, you know, because you can go to the right? Then, but you have to do a lot of hard work also, and a lot of risk is also involved. And then, when I will give a lecture on the coral reef mapping, some more risk. Then, also we did for Cebu Island as well. Okay, so you can skip. Okay, so we have already shown you for the two study areas, isn't it? Done. So let's move on. Okay, let's go through the process. Yeah. So image pre-processing. Then you have, of course, geometry correction. First step. Second, digital number 2 radiance conversion. Why is it? Why is it important? When you measure sea surface temperature, right? What do you do? Do you use actually straight away your pixel number or distal number, or do you convert actually to? How do you convert? How do you convert? L equals to
جين وبياس ذكرتني يا هدي.
L equals to
جين والبياس
dn.
اوفست.
There will be one parameter A. Then B, that will be offset. I barely remember. Huh? Right? Something like this? No?
اوفست.
No, not like this.
جين وبياس يا.
I studied it 25 years ago, or more than 20 years ago. So even though if I do a mistake, also acceptable. But you all are studying now. Yeah? I think something like that. Okay, anyway. So, image pre-processing, then you need to do this, a very important step actually, to calibrate the image properly. The digital number 2 radiance conversion. It's a simple step, but you need to, for each sensor, for each satellite sensor, you have the equation basically. Because this offset value also is constant. This comes actually
Offset.
when you want to apply this.
Each satellite has its own
That's so much. Yeah.
That can be.
So then, of course, you have to do the cloud masking. It's a very simple step for it. You need to do cloud masking, isn't it? Yeah. Then, land masking, because we are not interested in the land, so there is no point actually processing the whole thing there, which is 80% of the land is gone. It's not useful for you, right? So basically, you mask them out, remove them, throw them. Just use the data that is falling within the objective, correct? Then, see here, if I do the geometry correction, this is before it looks like, this is before, this is I think the what do you call, bodies, these are looks after. Well, the first one, it doesn't, not so much, but this one you can see here. Okay, the orientation has completely changed. Correct? Then the next actually is the digital number 2 radiance. See? A is the gain. A is the gain plus B. I was not sure if there is a plus or multiplication, but it's a plus. So 20 years ago also still okay. Okay, now let's look at it. So this is the digital number image, the first one. Once you convert, see this is the spectral profile, you can see this is the band number, spot, you have 1 to 4, correct? Spot doesn't have, spot 5 doesn't have which band? Blue band, okay? So that's why sometimes it's a problem when you want to do some applications. Okay, so this is the digital number value, you can see that. Varies between 0 to less than 100, about 90 something. So when you convert, apply these equations, so it changes actually from to 60. Okay, but the overall pattern, of course, the graph remains the same. This is for spot. For Landsat, same. You have actually more band, 6 band, then you have actually also same. Yeah. Depending on actually what band that you are using, correct? So for different band, you have different that offset value is constant. Okay, which band you are using. So this is the digital number. Well, in the image, when you want to visually see, you don't find actually much difference. So it's just a matter of changing the values, correct? Another way?
Yes.
We pray 5 times a day.
Right, here we
Asking. But that's only.
Okay, so you look here, the next process actually is cloud masking, quite bad. A lot of clouds, A lot of clouds, Mask it, throw it away. Then, yeah, you can use any type of method actually to mask them. It doesn't matter actually. Then, in the bigger one, Landsat one actually, we do the land masking. We are not interested in the Langkawi remote. We are just interested in the water bodies, correct? So, mask up, throw it,
Sorry.
correct? Now, let's do the water quality model. Okay, now, for planning purpose, as I mentioned to you, you know that this is the time the satellite is passing, exactly the same time we go to spring and quality. Okay? Definitely you should have different groups, Otherwise, one side of the day, you go along, collect the data, to pass there, already the satellite has passed. Correct? Right or wrong? Larissa? You need a big group. Let's say you have 10 or 14 points, right? So you should have a 14 group, basically. Because it passes very quickly. So, you need to synchronize your data collection procedure, timing, matching with actually the satellite paths. So you can be able to do the proper coordination analysis. And also you can apply the regression analysis, correct? To see that how do they fit based on your radiance value or your distance number value, because you're going to convert them with respect to the data that you are capturing in the water body. Alright? Same thing, yeah? For both. Okay, let's look at actually the first one. This is the first area. You can see that the location of the points or the sampling that we have done. So you need quite a lot of money and also a lot of people involved. Because some of them actually also you can see that middle of the river, middle of the lake. Okay? Then, yeah, this was captured long time ago, and we did it for actually 14 slices. Sometimes not.
What the general, the type of the testing
Yeah, I'll tell you. Have patience. I'll tell you. Definitely I'll tell you. Otherwise, how? What we collect is important to know as well. Correct? You don't go and do fishing anyway, right? Yeah, you need to collect some data. Yeah. So, but well, you plan 14, but not necessarily the 14 will be useful because 1 or 2 probably will be undercovered. So they need to be thrown out. Or because basically they cannot be useful for calibration purposes. Correct or not? So, but at least our attempt, before you go to the field, you must make sure that you cover most part of the area. That's what I call homogeneously distributed.
What about this? From certain?
Yeah, I'll tell you what are the parameters. I'll tell you. Huh? So, then the process flow. What is the process flow? You will not find all this information anywhere. I will tell you because if somebody would have done a project, going to the field, collect the data involved in this, then otherwise you will get just theoretical information. Alright, so see what are the process flow here. As I mentioned, synchronous data set, data coming from the satellite image converted to the distance number converted to the radiance. Okay. Then we have also the surface water quality data, right? Then very easy. You have 14 points here. Then you have actually the radiance value. Then you do the regression analysis. You found actually correlation. It's a very straightforward process in SPSS. Then you obtain a equation, the regression equation. That means the coefficient values you can be able to y equal to mc plus da 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 da. So all these coefficients you can be able to obtain actually from this regression analysis. Then you develop the water quality model. That is what I call it model because you develop this model using the regression analysis result. Then of course you do the validation and so on. Okay, now what we look at. There are different parameters to measure when you do the water quality mapping. Yeah, so this is actually the location of all the data. You can see. One important information you can see there is the TSS, total suspended cells. Okay, depending on the type of area that you are capturing the data, of course this value is going to change. Let's say you have extreme heavy precipitation and fog. Because basically the sediment load coming from the soil goes and also mixes in the water body, right? So that actually increase the amount of the TSS, right? So again, that is a standard classification of the TSS level. Okay, so you have, like you see, they have this specific actually is to which one you use for validation, which one you use for regression. Okay, but then, of course, this value also there is a, like our cholesterol, right? Cholesterol also we have, right? Bad cholesterol, good cholesterol. So that is also a separation. How much is permissible? The same thing, when in water also you have this contamination like nitrate, correct? Also there is a permissibility level, right? Always measured in milligram per liter.